So far we have been talking about classical optimization. We are now starting into numerical optimization, which is really what can be used for solving most engineering problems. We'll start with linear programming. We'll spend like 2 weeks in it. Then we'll go into nonlinear programming, which is again more common than linear programming, just because sadly enough, most engineering problems are nonlinear in nature. So let's see what is this linear programming means. Linear programming is optimization problem where the objective function and all is very important. So let me underline it. Equality and inequality constraints are linear. So nothing like x squared, x cubic, or square root of x or any nonsense like this. The problem was first defined mathematically in the 30s in the field of economics, and it became an important tool for allocating resources during the Second World War, where war planners in all countries have to move huge amount of soldiers, materials across the world, and they need way to economize the process, not to waste time, send soldiers, supplies, armament to places all over the world using fairly limited amount of resources, either typically ships or railway. So linear programming problems can be easily solved geometrically, as we'll see for the case of two variables and few constraints. However, most real problems are not with two variables and not with few constraints. So the dimensionality of the problem will make a simple manual solution impossible. So here are two examples. One is something you are typically complaining about every semester, that a school administrator with limited number of classes trying to fit a semester schedule according to the number of required elective courses. Each course has different enrollment, and many students also would like to have these courses as close as possible so they don't go back and forth across campus, even though it is very healthy for you, while you may not know how this. And by chance, actually, I just discovered this. Bill Gates solved this problem when he was an 8th grader for his school. And at this point, he just learned programming. So this is tell you how smart he is. Another problem that is again very common is airline with limited number of planes, and we are not going through the problem with the Boeing planes. And they are serving a schedule that is fixed between multiple cities, and they would like to minimize fuel cost. They would like also to minimize waiting time in airports. So there's many factors that makes a problem super formidable. So in 1979, before introduction of personal computers and Netflix and all this good stuff, 25% of all computational time across the whole world was spent solving linear programming problems. And I have source in case you are suspicious how I get this number. So I hope that you can see why studying this problem is important. So let's see what we have. Little bit of history. This will not be coming in the test, so you can turn off the video now in case you are not interested in history. The problem was first solved by George Danzig, who proposed the simplex method as a way to solve a linear programming problem. He was serving as the Air Force at the time, and his solution is simple and elegant, as we will see later. Danzig was not your everyday mathematician. Actually, when he was undergraduate, he solved a formidable statistics problem And this was used in the famous math assignment scene in Good Will Hunting. I have a link here. If you haven't seen the movie, it is a good movie. So it is a recommendation. In a very short, he came late to class, and at the time he came, the professor said, "Here is an interesting statistics problem that no one solved it." And he was just saying it. Unknown to Danzig, he thought that this was an assignment. So he scribbled it on a piece of paper, and he knocked on his professor's door 2 weeks later and said, "Here's the solution of your assignment." And the professor was stunned because he thought that he is joking or he covered it from some place the professor was not aware of. Finally, when they know that he's really a genius solution, they published it as paper while he was undergraduate. And this was his start of his career. So from Second World War, simplex method ruled linear programming till Narendra Karamakar from Bell Labs proposed different solutions. It was 50 times faster. And this will be covered in chapter 4 of your textbook, but we are not covering. Because of the limited time, we are just focusing on simplex method, as we'll see in next module. And here is Professor Karamakar. I don't think actually he's a professor, he just went to industry. Anyway, hope this will make you interested in the simplex method, and we'll see what to do in the next one.